The main problem with space travel is cost. To put you in orbit around the planet Earth costs about $10,000 a pound. Once you're outside the first 100 miles, you coast. You coast all the way out to Pluto. So if the first 100 miles is the only problem, why not have a space elevator where you simply hit the up button and you ascend up a cable into outer space? For a century, we thought that this idea of the space elevator was ridiculous. Now we have a new game changer: carbon nanotubes, and graphene. Graphene is one layer of carbon. It conducts electricity. It is the strongest substance known to science. And it will suspend a space elevator without breaking. Now, to be fair, the world's record for pure carbon nanotubes and graphene is only about that long. So we have a long ways to go. But it's a practical problem now. Theoretically, the main challenges have actually been negotiated. Why not dangle the cable down from the International Space Station and then anchor it perhaps to a barge in the ocean, which is a little bit flexible, giving it a certain amount of flexibility so it's not so rigid. It can open up the universe for the average person.
Hey folks, and welcome to another video from A Plain Truth. Well, check out this picture. Is this the carbon nanotube elevators in the process? Look at the frequencies, look at the wave, look at the middle beam there, using light particulate matters to send supplies, whatnot, up into the sky drones or platforms or whatever is up there in the ether or space, depending on what you want to use your terminology. So this is how they're supplying the ships above? Is this how the sun simulators are going to be refurbished? Is this how the solar power, the space-based solar power, Solarin Corp, is going to be providing all our power for our homes, all our power for our cars, all the power for the internet and connecting to the internet from these platforms? And this is how they're going to supply them, is through these nanotube elevators. So I put together a couple of my carbon nanotube videos here so you can get a little more in depth into how this is all coming about. But please note that the Michio Kaku or Kuku, whatever the guy's name is, this was from July 2011 when they were talking about this. So you know it's in place. You know it's real. In fact, here, let's take a look at the pictures of them so you can understand this is really going on right now. And will they be shutting off the power on the lands and running it all from the space? This is why we're having the fires, the hurricanes, and all the power going out. My feeling is that is exactly what is happening.
Here's a picture. Oh my God, guys. This is an interesting picture that was taken from a train in Denmark. And in the first picture, nothing. Second picture, Jacob's ladder or some such thing. Interesting stuff.
Nanotubes. Carbon nanotubes are long chains of carbon held together by the strongest bond in all chemistry, the sacred sp2 bond, even stronger than the sp3 bonds that hold diamonds together. Carbon nanotubes have numerous remarkable physical properties, including ballistic electron transport, which makes them ideal for electronics, and so much tensile strength that they are the only substance that could be used to build a space elevator. Yep, just like the one that Google is trying to build.
And the lady is correct. So here's April's Tax Fool Day on April 15th, 2014. And all these stories came out at the same time. But Google X trying to make one back in February, a group of scientists decided that building a space elevator should be totally doable by the 2020s. Confirmed Google tried to develop a machine that could transport things into space. Google X. Quote, the team knew that the cable would have to be exceptionally strong, at least 100 times stronger than the strongest steel that we have. He found one material that could do this, carbon nanotubes, but no one has manufactured a perfectly formed carbon nanotube strand longer than a meter. That's not true. And so elevators were put in a deep freeze. It will be exciting if Google gets back in the space elevator game, or did they ever leave it, folks? Well, again, let's look back at the dates here. This is, again, November 2014, same time frame. Look at the nanotubes, folks. Look at them going up here. Space elevators, more than science fiction. Goes through the Russians, goes through the Arthur C. Clarke, fiction writer who's also consultant for NASA. These futuristic engineering feats consist of a cable, also known as a ribbon or tether, of material stretching from the Earth's surface into orbit, an anchor in Earth's gravity at the lower end, and a counterweight and centrifugal force at the top end keep the elevator's cables taut and stationary over ground. Robotic climbers would then pull themselves up the ribbon from the surface through the stratosphere and out into space, potentially powered by lasers. Get that? Lasers. Is that what we're seeing in these pictures here? The climbers could carry satellites up and bring minerals from the moon or asteroids back. They could take tourists into orbit, blah, blah, blah. You could take a ride for the cost of an airline ticket. Yeah, they're going to give you a ride. But what's interesting about this is this International Space Elevator Consortium, ISEC, who's funding it, how are they funding this stuff, has been organizing space elevator conferences for a decade now. A decade now. So these guys have known about it a long time, more than 2014. The secret is find the right material. We're going to show this up in the video to get 62,000 miles high. Why that high? That's the geocentric orbit, allegedly. The current favored material is the mega cable, is carbon nanotubes. Mega cable is what they're calling it. Carbon nanotubes can be spun into cables and tethers just like a rope is made. Theoretically would be strong enough. We just figure out how to manufacture the ribbon out of these materials in large quantities. They've solved that problem. Once the material aspect is figured out, the rest is just engineering and political problems to solve. No political problems, we just won't tell you about it. So here, take a look at this.
Number 3, graphene. Graphene is the strongest material known to science at the present time. It is 200 times stronger than steel, and it is one of the strongest, thinnest, and lightest material in the world. Graphene is a single layer of pure carbons arranged in a hexagonal lattice pattern. It is so thin it is considered to be a two-dimensional object. This newly discovered material might be one of the most important known to man. It has amazing thermal and electrical conductivity properties, and it is also very malleable but at the same time very strong. This easy and simple yet groundbreaking experiment was conducted by Andrei Geim and Konstantin Novoselov. They later won the Nobel Prize for Physics because of these experiments. Graphene is definitely going to have an impact on the world. The specific strength of carbon nanotubes is 48,000 kilonewtons per kilogram. The previous record holder for structural strength was high carbon steel with a measly 154 kilonewtons per kilogram. That's 300 times stronger than steel. You could build towers hundreds of kilometers high with it, or the world's strongest and tiniest straw. Your pick.
Now, if you think the whole idea of an elevator to space sounds like science fiction, you're right. It was popularized in the late 1970s in a sci-fi novel called The Fountains of Paradise by Arthur C. Clarke.
At last, we can build the space elevator, and then we will have a stairway to heaven, a bridge to the stars.
But as long as people have dreamed of building that bridge to the stars, no material existed to make a cable that's strong enough. That is, until we found that one of nature's most common atoms, carbon, was leading a secret life.
Here's a picture. Oh my God, guys. This is an interesting picture that was taken from a train in Denmark. And in the first picture, nothing. Second picture, Jacob's ladder, or some such thing. Interesting stuff.
So how would we ever use these tiny tubes to make a cable that's 22,000 miles long? Deep in the heart of Texas, scientists are taking a different approach to assembling carbon nanotubes.
It's the dream of the future, but it's an achievable dream.
To make a batch of carbon nanotubes, bake a silicon plate coated with iron particles at 1,300 degrees Fahrenheit in a special oven. Then add a dash of acetylene, a gas that contains carbon. When acetylene comes in contact with the iron, it releases its carbon atoms, which assemble, as seen here, into nanotubes. When the plate comes out, it's coated with a black soot that contains trillions of carbon nanotubes, all aligned vertically in what Ray Bachman calls a forest.
Think of a bamboo forest.
But unlike a real bamboo forest, the trees in a nanotube forest tend to stick together, thanks to a faint force operating at the nanoscale, called the van der Waals force. It's sort of like magnetism.
So when you pull one nanotube out, you pull its neighbors, and then they pull out their neighbors.
Pulling a whole row of nanotubes from the forest on the left, they can draw out a ribbon of pure carbon nanotubes, held together by nothing but the van der Waals force. This ribbon is less than 1,000th the thickness of a human hair, and it's stronger than steel. But can nanotube ribbons ever be made strong enough for a space elevator cable?
That is an unresolved question. But in science and technology, I've learned to never use the word never.
So coming up is a clip of a university's competition, it looks like, to put some strands of carbon nanotubes up and push something up in towards space. And I want you to see if you can see any nanotube fibers or not. Carbon, I could not see any. So does that mean it's invisible or not? Or is the carbon nanotubes part of the cloaking device they are employing here as well, to hide the structure for transporting things up and down the ladder, so to speak, Jacob's ladder?
Favored to win is the University of Saskatchewan Space Design Team, or USST for short.
Go time, right? It's go time.
Their secret weapon, a stationary mirror to reflect a spotlight straight up the ribbon to the solar array.
Go back a little bit. Hey, back. Phase one.
It looks like they'd make it to the top in record time, fast enough to claim the $150,000 prize. So they win?
We have to have a little discussion about that.
Before the prize money can be awarded, the remaining teams get one last chance.
So now the question has to be asked, with all these private corporations, Elon Musk and Bezos and these guys allegedly throwing rockets up into space and sending stuff up there, and Microsoft building a super airplane, the world's largest, to launch a space shuttle into the stratosphere to carry payload and whatnot. What are they bringing up there? What are they taking up there? Is this to service all these space mirrors and ships and shenanigans they've got going on here? Is this a space elevator we're seeing of carbon nanotube fibers and whatnot? Is that a delivery system for them building things above us, as Skynet, as Lana Freeland so appropriately put out in her book about the fence that is a must read? What is going on up here? Well, let's take a look at the machines and how they may be fitting right into the nose cones and everything of these rockets, and they're just putting the sky fence right over us, the Skynet, as we speak, and we're watching in real time our own enslavement going overhead right now. Sad to say, but sorry to report, but that's what it looks like is going on to me.
And then here's these classic sundogs like we talked about. Again, I just want to explain to you guys, when you see this, these
much brighter than they are. This is where the star shade comes in, to help block that bright light to better help astronomers learn more about these mysterious planets and look for biosignatures for life.
One of the ways in which we're thinking about suppressing the starlight is using something called star shade, which is a very large external occulter that flies in front of a space telescope and blocks out that starlight so you can image that really faint planet right next to it.
Sounds easy enough, but the star shade is roughly the size of a baseball diamond.
Because
star shade is roughly the size of a baseball diamond.
Because the star shade is so huge, we have to come up with a way of folding up this very large structure into a space so that we can launch it inside a rocket. And once it gets to space, it can unfold itself.
One origami project currently in development at NASA's Jet Propulsion Lab is the Star Shade, which is essentially a big star blocker.
the storm, riders on the storm. Into this house we're born, into this world we're thrown, like a dog without a bone, an actor out alone, riders on the storm. There's a killer on the road, his brain is squirming like a toad. Take a long holiday, let your children play. If you give this man a ride, sweet family will die. Killer on the road, yeah. Girl, you gotta love your man. Girl, you gotta love your man. Take him by the hand, make him understand. The world on you depends, our life will never end. Gotta love your man.
What we've designed, and we've done this very, very quietly, but we're glad to now release it to the world, is this idea of Teslaphoresis, which is a discovery we made several years ago, and we've been developing it. And Teslaphoresis is, the simplest way to understand it is self-assembly at a distance, just long distance assembly of materials. And what we did was, because we're at Rice, we had plenty of nanotubes around, so we decided to use nanotubes. And what we discovered was that these nanotubes can actually string together and form wires by themselves under this electric field.
This fundamental idea of force acting at a distance, that you can have, instead of, when you normally build circuits and things like that, you have to have physical contact. Now we're talking about building circuits without actually touching them.
All right, we're just dispersing this. Power on, and up. I realized that a Tesla coil could actually do this if you designed it in a way to create a very strong force field in front of it. And so that was the engineering aspect of it. And then once I designed the machine, then all sorts of discoveries started falling out of it. Oh, that was a good one!
Tesla-phoresis is one of those things, it's a project that there are just so many avenues, so many things that I think you can do with it. Not just making conductive wires, but taking it in so many different places, not only just biomedical and engineering, but taking it into different industries like silicone chips or exploring different conductive materials.
This also ties in just generally in nanotechnology that self-assembly is very big. That is, if you can get things to build themselves, just as in biology, we build ourselves.
When my son saw it, he called them webs. You know, he thought it was like Spider-Man shooting webs out. And it really is. It's very much like a web sort of stringing out together. And that was a surprising finding. And the physics of that is actually a lot richer than what we had originally thought. So there is new science coming out of this as we go.